Hi friends, welcome to our channel. Here we are going to look at problem 3483, unique three-digit even numbers. Our plan in this video will be the following. We are going to practice some brute force methods. So though we see brute force, actually this method can be fundamental and very important. So here we are given an array of digits called digits. And our task is to determine the number of distinct three-digit even numbers that can be formed using these digits. So here, each copy of a digit can only be used once per number, and there may not be leading zeros, right? So here, we are going to find distinct even numbers. We know from mathematics, if the three-digit number to be an even number, we need the last digit to be even, right? That's the criterion. So if you look at the examples, this one is very special. You just have one. This is zero, right? For this one, you can also adjust this. It's going to be 12. And the important thing in this problem is the constraint. So the constraint basically tells us the problem size. You know, here the digits is bounded above by 10, right? So this is the problem size. The lower bound actually is a consistency assumption because we need to find three-digit numbers. In other words, we need to have at least three digits, right? Because it's digits, so they are between 0 and 9, right? So with that said, we're ready to do our coding. So here, because the logic is so simple, we're not going to do some walkthroughs. We're going to look at code directly. But our main purpose is the backtracking method. So first, I'm going to write a solution using nested for loop. First, we're going to have this the n digits, right? So this n is for convenience because the length is actually a digit, is an attribute of this object, right? So you just access it in one time. So with that said, I'm also going to initialize a result set. This is the set because we want to avoid repetition, right? Then we are going to use a simple for loop for I in range n and for j in range n and for k in range n, right? And then we want to do this one. Each copy of digit can only be used once per number. So the criterion will be the following. If I does not equal to g, and I does not equal to k, and g does not equal to k, right? And then if this condition holds, we can further consider the thing. First, if digits I is not zero. In other words, we are going to consider using the index I number as the address, right? And then we need no leading zero. So this is the condition. And also we want the number to be even. In other words, digits the k modulo 2, it should be zero, right? If this is the case, so we are going to do what we are going to do is result set. We're going to add this number 100 times digits y plus 10 times digits g and plus digits t, right? And then what we are going to return is the length of this result set. So this is the full coding of the problems. You can see the logic here. From here, this is the one. Each number use once, and there's no leading zero, and this is an even number, right? So this is the decimal representation of this number. So now let's first run it to test. Yeah, it passes the four cases. Now let's look at the generic case. Yeah, it passes all the cases. So this should be okay because of the problem size. However, if we do write this nested loops, it's not our main purpose. Our main purpose is to do backtracking. Still, backtracking is recursively construct all the numbers, but it's a little bit advanced than the nested for loop. this is the one reason we do this. Another reason is that backtracking is a very important technique, and you can use this technique to address quite a large number of problems in LeetCode or in your daily work. So now let's look at the second version. So I'm going to copy this class and function signatures below and mark this one as version v1. So now let's look at this one. So first, I'm going to basically the same thing. We can use a result set to hold all the numbers, right? So then I'm going to use use. It's also a set. Is to avoid repetition in the backtracking function. So now I'm going to write a backtrack function. So starting from a digit, right? So then what we are going to do, the code structure will be the following: backtrack starting from 0, and then we are going to, for this call, we are going to return the length of this result set. In other words, this backtrack function is going to modify this result set. In other words, it get all the possible 3-digit even numbers and then put it into the result set. So that's the purpose of this backtrack function. So this should be straightforward or parallel in the first version. So now let's first see if digit modulo 100. So this, if this is not 0, right? And then if a digit modulo 2 is 0. So in this case, we are going to add this digit, right? So the result set. And then we are going to return, right? So in other words, once we have a 3-digit number, then if it were an even number, we are going to add it to the result set. Otherwise, we just finish the construction. So that's the one bounding condition. And then we are going to do the backtracking step for I in enumerate. So digits, right? So then if this index not used yet, if not in used, so in other words, we can still use this number, right? So used, let's first add it to used. And then we can backtrack. And then so we use this one and use this digit. So add the next digit. So originally we have a digit or a number. So we can do digit times 10 and plus n, right? And then we are going to do backtracking, right? So it's going to be remove this I, right? So this is the full logic. So in other words, if, for example, you want to construct, let's see, you want to construct 1, 2, 3, you first use 1, and then you use 2. So the 1, 2 corresponds to 1 times 10 plus 2, that is 12. So next time you are going to use 3, so you're going to have 12 times 10 plus 3. That is 1, 2, 3. So notice that this function is recursive, right? So in every step you get a digit, then you are going to multiply that digit by 10 and then consider the next one. So that's the logic. And this is the way you should think of backtracking. So now let me first test it. Yeah, it passes the 4 cases. Now let's look at the generic case. Yeah, it passes all the cases. So with that done, I guess that's basically about it for the 2 solution formats. So let me give a quick summary and make one comment. So in the first version, we used nested for loop, and we encode the conditions here and here in the 2 if loops, in the 2 if conditions. So this is the version v1. And in version v2, actually we are doing backtracking. You can also understand it as recursive DFS. This is second version of solutions. That's basically the quick summary. The comment is that, so in our YouTube channel, we have a playlist for traversal or backtracking. You are welcome to check out those problems there. I guess it would be beneficial for you to do such problems. With that said, I guess that's it for the current video. Thank you for watching.